Oh, that's a cool effect. I don't know if this is going to show up on the video, but there's like these three colored bands. It might be like the refraction from the I have the window open next to me, or I mean it's definitely the projector because it's the colors of the projector. But this is really cool. What a happy what a happy experience. I don't know how to describe that. That's cool. Hello, Applied 30. Welcome. For this lesson, we're going to look at the equation of the standard quadratic. Last lesson, we did some vocabulary and just kind of see what a quadratic looks like. Now we're going to get into some of the math with that as well. So the equation itself, it's always going to be a y equals or an f of x equals situation. In this case, we're going to start with y equals ax squared plus bx plus c. Now, there are a few things that you need to watch out for with this equation. The first one, it's very important, is that a cannot be 0. If a was 0, if this value was 0, you end up getting 0 times x squared, and that x squared is what's making our graph curve. You'll see it in just a moment. But if a is 0, you get 0 times x squared, and that eliminates what should be a curved graph. And what you're left with is bx plus c. So you end up getting y equals bx plus c, and that looks very similar to y equals mx plus b. You get a linear relationship there. So that's why a can never be 0. B and c, we're going to say that they can be elements of the real numbers, meaning they can be anything you want them to be. Preferably they're nicer numbers. You know, natural numbers, whole numbers, or just integers, but sometimes you can't work with that. As long as a is not 0, you should be okay. So here's an example of what a quadratic looks like, and I'm going to manipulate that just a little bit. First, we're going to talk about a, which is going to determine the direction and the width of this quadratic. So if you have a positive a value, in this case I've chosen positive 2 for this red quadratic, it means that your graph is going to open upwards. We call that concave up. So if this is kind of like a spoon, the part that would hold the liquid, that's facing upwards. That's concave up. That's always when a is going to be a positive value. Now, if a was a negative value, we instead would get something concave down. So now you flip your spoon over, the liquid is now facing downwards. Not really a great spoon, but it's concave down. So you get this hill shape happening instead. The a value also determines how wide or how skinny your graph is going to be. So the larger your a value gets, the skinnier your graph gets. So right now our a value is negative 2. I'm going to change it to negative 10. And you might notice, blue graph now, they're overlaid, and the negative 10 a value has a skinnier graph than the negative 2. If I make my value smaller for a, so make it into a fraction, we end up getting a wider graph. So instead of doing negative 2 or negative 10, I'm going to do negative 1/4 or negative 0.25. And that gives me the green graph. I've actually overlaid negative 1/2 as an a value as well. That's the purple graph. Simply because the green one, negative 1/4, is so wide that it doesn't even fit on the screen. So negative 1/2, as you can see, it's the widest graph that we have, and it does happen to fit on the screen. Now, another value that might be of interest to us, is the c value. That's going to be our y-intercept. And that's because if x was equal to 0, that's where we would find our y-intercept. If x was equal to 0, you end up getting a times 0 squared plus b times 0 plus c. Well, the a times 0 squared and the b times 0, they cancel out because it's times 0, and you're just left with y equals c. So no matter which equation you have, your y-intercept will always be your c value. On these graphs, you can see that, no pun intended. On these graphs, you can see that because it's the exact same graph over and over and over again. It's just I've changed the a value, so they all have the same c value, so they all cross over at positive 4. So I'm going to leave you with that for the equation, and on the next video I'm going to show you how you can calculate the axis of symmetry, and that's the line that tells us how to split a graph perfectly in half.